Hello, welcome to, this will be a video tutorial on your Longbowman worksheet. This video will be dealing specifically with the first problem, where you are given the range and you are asked to find the initial velocity. Now, those of you that are watching this are about to be seriously rewarded, because I'm going to walk you through this entire worksheet, step by step, all the work, helping you so you can get 100 on this. So, what we've got is, let's go ahead and get a horizontal distance, and this is 400 yards. Now, you're going to have to do a little dimensional analysis, I know, but you can do it. And we start on the ground, and we end on the ground. And we have an initial velocity, which is what we are looking for. We don't know what that is, but we do know that our angle, get on there, our angle is 45 degrees. So, we know our angle, we don't know V naught. Okay, we do, however, know our dx. Okay, our dx is 400 yards. Now, how helpful are yards going to be in this problem? Not very helpful. So, we need to convert that to meters. Well, to do that, we know that 1 yard is 3 feet. And I know that there are 3.281 feet for every 1 meter. So if I just do the math here, I would get 365.7 meters. That is my distance in the x direction. So we all know that dx, or our distance in the x direction, equals our velocity in the x direction times time. Well, we don't know how long the arrow is in the air, and we also can't find Vx because we don't know V naught. Okay, but we do know that Vx is V naught cosine of our angle. In this case, our angle is 45 degrees. Okay, cosine is for the x, always, always, always. So let's take this and replace Vx with that. So our dx equals V naught cosine of 45 degrees, and then all of that times time. Now, I'm going to call this equation 1. Okay? So, let's think about what else we know. We start on the ground and we end on the ground. Well, that means that delta y, very important, delta y is 0. Well, the equation involving delta y is delta y equals, we've got V naught y t, and then plus 1/2 a t squared. Again, I don't know t, and I don't know V naught y, but I do know that V naught y is V naught sine of 45 degrees. Okay, so what if I replace V naught y with this right here, rewriting this as 0 equals, instead of V naught y, I'm going to have V naught sine of 45, and then that times time, and then plus 1/2 a t squared. Now, I'm going to call this equation 2, because if you look at these two equations, I have two unknowns. Because this equation turns into, I know dx is 365.7. Well, that equals V naught cosine of 45 degrees times time. And down here, there are only two unknowns. I don't know V naught and I don't know time, but I do know my acceleration. It is negative 9.8 because our Longbowmen are on Earth. So, two equations, two unknowns. This is so helpful on the ACT. At least 3 or 4 questions deal with system of equations. System of equations is 2 equations and 2 unknowns. So what I would do is I would solve this equation For t, I'm going to divide both sides by v naught cosine of 45. So divide over here by v naught cosine of 45 degrees. So, excuse me, v naught y. This over here cancels. That leaves me with t on this side. And over here I've got 365.7 all over v naught cosine of 45 degrees. Now, I'm going to leave it like this, and I'll show you why in just a second. So, once you solve for a variable in one equation, plug it into the other equation. So, instead of t, I'm going to rewrite this equation as 0 equals v naught sine 45 degrees. But now, instead of t, I'm going to write this. So I'm going to write 365.7, I get my point in there, all over v naught cosine of 45. And then plus 1/2. A is negative 9.8. And then instead of t squared, I'm going to put this in parentheses, 365.7 all over v naught cosine of 45. And I'm going to square that whole thing because t gets squared. So this whole thing gets squared. So now, if you look over here, I've got a v naught on top and a v naught on bottom. Gone. Now, sine over cosine. Sine over cosine is actually, do you remember? Well, in case you don't, it is tangent. And a beautiful thing about this, tangent of 45 degrees is 1. Ho, 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 ho. So, this goes away in a sense because it's just 1. So we end up with 0 equals. So far I've got just 365.7. Now I'm going to go ahead and distribute this 1/2. So I'm going to go minus 4.9. Now this whole thing squared. I've got to square the top. So 365.7 squared is, it's a big old number. It's 133,736.5. And then all of that over. This gets squared, so v naught squared. Squared. And then cosine also gets squared. So it's cosine squared of 45, not cosine of 45 squared. It's just cosine of 45 times cosine of 45. Oh, excuse me, let me close those parentheses there. So now, we go about it just the same way. I've only got one unknown now. It's v naught, it's right here. So let's get this by itself. I'm going to subtract 365.7 from both sides. So that gives me negative 365.7. Let me get my point in there. And that equals negative 4.9 times. Now, up top, I'm going to keep that as 133,736.5. All of that over v naught squared. Now, in your calculator, if you go cosine of 45 times cosine of 45, being sure to close off your parentheses like this. Cosine of 45, like so. And then that times cosine of 45. It comes out to 1/2. So I'm going to write times 1/2 down here. Okay? Now, again, we're still trying to solve for v naught. So, let me shimmy this down a little bit. So what I can do is I can divide both sides by negative 4.9. Get rid of that 4.9. So divide this side by negative 4.9. So that gives me, on the left side, that gives me 74.63. And that equals, again, on top, I've got 133,736.5. All of that over. I'm going to flip those around because I don't like the variable coming first. So I'm going to write 1/2 v naught squared. Now I know that looks weird, but here's a beautiful thing that we can do. I've got V naught on bottom. 74.63 is really over 1. It's just not written. So I can cross multiply. It's a beautiful thing. So 1/2 times 74.63 gives me 37.3 V naught squared. And that equals, oh, I'm sick of writing this number, 3736.5. Now, all we do is solve for V naught. So divide both sides by 37.3. Divide both sides by 37.3. So I get V naught squared equals, plugging that in your calculator, you get 3,583. And let's go ahead and add the change on there too, 86. Last step is to square root both sides. So you get an initial velocity for your English longbowman of 59.87 meters per second. Now think about that. Whenever you were finding, those of you that had the pleasure of working with the Nerf guns, the initial velocity of those only got up to about max 14 meters per second. So this is a big number. These arrows were moving very quickly, and they were coming down with a lot of force. Now, sidebar. Longbowmen came around first when the English were fighting the French. And so the French had plated armor, and the English needed a way to get through that. Boom. Something going 59.87 meters per second would definitely do the trick. So, that was part A. Part B asked us for time. So let me shimmy on down here. B wanted to know how long the arrows were in the air. That's a crappy question mark. There we go. So what we can do is we can use this equation, the equation 1 from way before, right here, equation 1. dx, first dx equals vx times time, but since we don't know vx, we know v naught, we just calculated it. So dx, let me just write it again, equals vx times time, and we know that vx, to find vx, we use v naught cosine of 45 degrees. Well, we found out that dx earlier was 365.7. Now, v naught, we just found it out. It was 59.87 cosine of 45. Do you see how I just replaced vx? Right there. And then all of that times time. Well now, oh beautiful, I'm just going to divide both sides by 59.87 cosine of 45. Now that gets a little tricky to do in your calculator. So what I would do is I would plug that into my calculator first, 59.87 cosine of 45. So let's do that real quick. That gives me 59.87 cosine of 45. It gives me 42.33 t. So now I'm just going to divide 42.33 on both sides, and I get a time of 8.64 seconds. So those arrows are in the air for 8 seconds. That's how long you have, if you're a French soldier, to watch those arrows come and try and dodge them. Now, you can dodge one for sure, but you can't dodge a wall of thousands of arrows coming at you. So that is part 1 of our Longbowman worksheet. If you go to the next video tutorial, I will walk you through problem 2.